Good evening. Today we are going to see the problems that are first day exercise. In this, we will go with first problem. A beam having cross section in the form of a channel as shown in figure. It is subjected to bending moment about x-axis. Calculate thickness T of the channel in order that the bending stresses at the top and bottom are will be in the ratio 7:3. So we are in this mesh. So we have given this and we are interested to solve this problem. So now we are going to consider that is this distance, let us we will say y bar. So we have this bottom that will be 250 minus y bar. Now by using similar triangles, we can have y bar upon 7 and that is equal to 250 minus y bar divided by 3. From this we will get 3y bar is equal to 1750 minus 7y bar. So if we will take 7 on this side, then we are going to get therefore 10y bar is equal to 1750. And from this we will get therefore y bar that is equal to 175 millimeters. Now we will find y bar of this section. So we have y bar that is equal to value we have 175 and that is equal to, first we will consider these two rectangles. So this is 250 into T and will act at center. So that is 125 millimeters. So 125 center. We are taking moment about top. So we have equal to 2 into 250 into T. 2 we have both sides. And into 125 moment about top. Plus we have this is second part. Now we have this distance. We will subtract T from both sides. So we have this as 600 minus 2T. So this distance from this to this. So we have this as 600 minus 2T. So we have plus 600 minus 2T into T into, we have this distance. Center we have T by 2. And so we have 250 minus T by 2. So into 250 minus T by 2 divided by, we have total area 2 into 250 into T plus 600 minus 2T into T. And then we will have this as 175. This is equal to, then we have 250 into 2 into 125 and we will get this value 62500T 62500 into T. Then we have plus, now we have this T by 2, so we will take that inside. So we have that T also we will take inside. So 600T minus 2T square. And here we will take 2 base. So we have 500 minus T upon 2. And divided by, if we will solve this, then we have this will be 500T plus 600T minus 2T square. Now from this we will take 2 common and that 2 will get cancelled with this and we can write it as 175 equal to 62500 plus T plus, as we have taken 2 outside and cancel with denominator, so it becomes 300T minus T square into 500 minus T and divided by 1100T minus 2T square. And now if we will solve this, so we have 175 equal to 62500T. Then if we will solve this, we have 15,000 plus this 300 into 500. So we have 15,000 T. Then we have 300 T square minus. Then we have minus 500 T square. So it becomes minus 800 T square. And then plus T cube divided by 1100 T minus 2T square. Now, if we will cancel T from all terms, that is numerator and denominator, then we will get 175, this is equal to, and then we will add this. And by this, we will get it as 175 into, I will write it as 1100. We are cancelling T from all minus 2T, which is equal to, we will add this 62,500 plus 15,000. So we have 77,500. Check it once, 500 minus 800T. We have cancelled T from numerator and denominator plus T square. And from this we will get equation, that is T square minus 450. T square minus 450T plus 20,000 equal to 0. Plus 20,000 equal to 0. And solving this, we will get two values. One value we will get T equal to 400. And another value we will get T equal to 50. Now T equal to 400, this value not possible. Not possible. Why not possible? So because we have this will be 600 minus 2T, and if we will put T equal to 400, then 600 minus 800, which is not possible. And therefore we have, therefore T equal to 50 millimeters. T equal to 50 millimeters. Now we will go to the next problem. So we have this problem, that is a rectangular section. So we have a rectangular section of beam 40 millimeter by 200 millimeter. Is simply supported and carries UDL of 8 kilonewton meter. So we have this UDL, it is 8 kilonewton meter. If the bending stress is not to exceed 125 MPa, so if I will plot bending stress diagram, then we have this rectangular section. So we have on both sides 125 MPa. So we have, this will be bending stress diagram, 125 MPa. This also 125 MPa. And then we have to find longest span L. So we have to find this value of L. So now we will go with, we know formula, we have sigma is equal to M by I into Y. Now calculate one by one values. So M, we will have WL square by 8 for simply supported beam. W we have 8. So 8 into L square by 8. And this will be equal to L square kilonewton meter. Then we will find I, which will be equal to B d cube by 12. And we have Y that is equal to d by 2, that is 200 by 2, which is equal to 100 millimeters. Sigma is given 125 MPa. Now we will substitute all these values. So we have sigma equal to 125. M is given L square into 10 raised to 6. Because Newton millimeter we have to consider. I we have 40 into 200 cube upon 12, and into Y we have 100. Now solve this value. By solving this, we will get value of L that is equal to 577,577.36 millimeters. And if we will write it, so L longest equal to 5.78 meters. So likewise, we have to find value of L longest. And now we will go with last problem. That is, find width of flange B for the cross section of beam shown in figure such that bending compressive stress is 3 times bending tensile stress when subjected to sagging bending moment. Sagging means we have again beam and simply supported. And we have top compression, bottom we have tension. And therefore we will draw this diagram. And in this diagram, we have compression 3 times. And we have tension 1 time. So if I will write it as 3 sigma, and this becomes your sigma, 1 sigma. And then we have to find bending stress. So now again in the same fashion, we have this as Y bar, and this total depth we have 100. So we have this will be 100 minus Y bar. And then if we will go with this, then we have Y bar that is equal to, or Y bar upon 3 sigma, and that is equal to 100 minus Y bar upon sigma. And this sigma gets cancelled, and we have therefore Y bar that is equal to 300 minus 3Y bar. And from this we will get therefore 4Y bar that is equal to 300. And from this we will get value of Y bar. This is 80. This is 20. So 4Y bar that is we have equal to 300. And therefore we will get Y bar that is equal to 75 millimeters. So now we know this value 75 millimeter. So we will use for this, and then we have Y bar that is equal to. So first we have this 20 into 80. So we have 20 into 80 into 40. Moment we are taking top plus B into 20. And then from centroid, so we have 10 here. So 10 millimeters. So 10 plus 80 into 90 divided by 20 into 80 plus B into 20. Now you can see we have 20 in all terms. So we can cancel 20 from all terms. And Y bar we have 75. So we have 75. This is equal to 3200 plus 90B divided by 80 plus B. And then when we will multiply it, we have 80 into 75 plus 75b, that is equal to 3200 plus 90b. And then from this we will get 80 into 75, we have 6000 minus 3200, and that is equal to 90b minus 15b, sorry, minus 75b. And from this we will get 15b, that is equal to 2800. And from this we will get value of b, that is equal to 186.67 millimeters. So likewise, we have to solve the problem. And we have B 186.67 millimeter. So these are the questions, answers for first part. So second part we will see in next video. So thank you.